Hello and welcome to Math 8 Unit 4A Lesson 6. Today's objective is we're going to perform mathematical operations on numbers written in scientific notation. Mathematical operations are just adding, subtracting, multiplying, and dividing. That's it. Okay, so let's talk about how can I add or subtract. Adding and subtracting follow the same rules. So first of all, your exponents must be the same. As long as they're the same, then you're going to add or subtract the coefficients. Remember, the coefficient is just this first part. So here I'm just going to add the first part. They're both 10 to the 8th power. So I get 6.4 times 10 to the 8th power. Not that hard to do. Next one again, I've got 10 to the negative 8th power for both of them. So I'm just going to subtract this part. 8.7 minus 1.2, 7 minus 2 is 5. 8 minus 1 is 7, and I bring down my decimal. And then again, we just bring down r times 10 to the negative 8th power. Okay, well that's pretty simple. So what do I do if the exponents are different? Well, that's easy. We're just going to change the lower exponent to the higher one and then add or subtract. So how do I do that? So you'll notice this first one I have 10 to the 9th power and 10 to the 8th power. 10 to the 8th power is lower. So I'm going to change this one. I'm going to do that. So I'm going to put my 2 and my 7. And then I need it to be 10 to the 9th power. So because I'm making my exponent bigger, I need to make my number smaller. So I'm going to move my decimal over one space to the left. So it becomes 0.27. So I bring over the 3.1 and make sure to keep my decimals lined up. Times 10 to the 9th. And then I can add these. So this becomes 3.37 times 10 to the 9th. Okay, let's try it over here. I have 10 to the negative 8th and 10 to the negative 9th. Well, 10 to the negative 8th is actually bigger. Because remember, negative numbers, negative 9 is further left on my number line than negative 8. Negative 7, negative 6. So negative 8 is the bigger number. So I'm going to change this one to negative 8. So this can become 10 to the negative 8th power. And because I made my exponent bigger, again, I'm going to make my number smaller. So that becomes 0.12 times 10 to the negative 8. So again, I'm going to make sure I line up my decimals, 8.7 times 10 to the negative 8th. And we're subtracting. So I end up with 8.58 times 10 to the negative 8th power. Okay, not too bad. Okay, what about after I add or subtract? We have to make sure the number is still in correct scientific notation. What do I mean? Well, let's look at this problem. I've got 10 to the 8th for both of them, so I can bring down my 10 to the 8th power. And we are adding these, so 8 plus 9 is going to give me 7. I'm going to carry a 1. 5 plus 1 is 6, plus 4 is 10. So I'm left with 10.7. The problem is, of course, we said that we only get one digit left of our decimal. So I'm going to need to move this. I can make this number smaller, which means I make my exponent bigger. And if I was subtracting and I got a number that was less than 1, I would have to make the number bigger and make my exponent smaller. Okay, so now let's talk about how we multiply in scientific notation. So this is actually pretty interesting. So everything happening here is multiplication. We have a multiplication symbol here and here. And remember that these parentheses next to each other mean that we're multiplying. So all of this is multiplying. We know in multiplication, order doesn't matter. 2 times 3 and 3 times 2 are the same thing. So I'm going to rewrite this with them written a little differently. So I've got 4.3 times 2.8 times 10 to the 7th times 10 to the 9th. Okay, so I'm going to do 4.3 times 2.8. And I can do that with the calculator, or I can do it here like this. 8 times 3 is 24, carry the 2. 4 times 8 is 32, plus 2 is 34. Space holder. 2 times 3 is 6, 2 times 4 is 8. And then I'm going to add those up and put my decimal in the middle, so that becomes 4021. So that becomes 12.04 times 10 to the, now my rules told me that if I have two exponents that I'm multiplying, I simply add 7 plus 9. I add their exponents, 7 plus 9 gives me 16. And again, notice I went out of scientific notation, so I've got to change that back to 1.204. I made it smaller, so I make my exponent bigger, times 10 to the 17th power. Okay, let's look at that down here with this other problem. Again, I'm just going to rewrite the order. So I've got 1.2 times 3.5 times 10 to the 5th times 10 to the 10th. Okay, 1.2 times 3.5, 1.2 times 3.5. 5 times 2 is 10, 0, carry the 1. 5 times 1 is 5, plus 1 is 6. My space holder. 3 times 2 is 6. 3 times 1 is 3. So I have 0, 2, 4. And I have 2 digits left of the decimal, 1 here and 1 here. So I move it over 2. So that becomes a 4.2. So this is 4.2. 10 to the 5th power times 10 to the 10th power is 10 to the 15th power. Okay, that's not too bad. What about dividing in scientific notation? So dividing in scientific notation, it's a little easier to see this way. If I write it this way, 4.6 times 10 to the 9th over 2.3 times 10 to the 5th. And what I'm going to do is I'm going to break this up. So I'm going to pretend like these are two separate. I'm just going to erase this stuff in between them. Like those are two separate fractions. Okay? Well, 4.6 divided by 2.3 is just 2. 10 to the 9th power divided by 10 to the 5th power. We subtract our exponents. 9 minus 5 is 4, so that's 10 to the 4th power. Not too bad. Let's try it again over here with this one. So I've got 7.2 times 10 to the negative 7th power over 2.4 times 10 to the negative 5th power. Again, I'm going to erase this right here and pretend like these are two different exponents. Okay, so 7.2 divided by 2.4 is, let's see. So remember that we have to move this decimal over. So we move this decimal over so neither one of them has a decimal. The bottom is a 24. How many times 24 go into 72? I'm going to say 3 times. 3 times 4 is 2. 3 times 2 is 6. Carry the 1 is 7. Yep. So it's 3. So I get 3 times 10 to the negative 7 minus negative 5. Remember, so negative 7 minus negative 5 turns into plus. Negative 7 plus 5 becomes negative 2. 10 to the negative 2nd power. Not too bad. Okay, last thing. After we divide or multiply, we have to make sure the number is still in correct scientific notation. So, we're going to do 2.5 times 10 to the 5th times 5.4 times 10 to the 3rd. So I know it's going to be times 10 to the 8th. So 2.5 times 5.4 is going to give me, well, let's see. 13.4. Okay, but of course that's not incorrect scientific notation. So I have to make this number smaller. This is 1.34. I made it smaller, so I make this bigger. Times 10 to the 9th. We do the same thing over here. I have 1.75 divided by 2.5 times 10 to the negative 4th over 10 to the negative 8th. Okay, so 1.25 divided by 0.25 gives me 0.5. Over here, 10 to the negative fourth, negative 4 minus negative 8 turns into negative 4 plus 8, which is 4. Okay, but again, 0.5 doesn't work, so I need that to be a 5. I made it bigger, so I make my exponent smaller, so that becomes 10 to the third is my final answer. Okay, so go ahead and try these in class, and I will see you if you have any questions.